Namaste everyone. Here is a problem related to current electricity. Determine the voltage drop across the resistor R1. Where is R1? R1 is here. Determine the voltage drop across R1 in the circuit given below. E is 16 volts, so we will transfer it to the diagram. 16 volt. Internal resistance 2 ohm. Okay, 16 volt 2 ohm. What is the voltage across R1? Okay, so the problem can be, see, whenever you have a problem like this, you will have to reduce the circuit to the most simplest form. The reducing the circuit means you should just replace all the resistors by a simple single resistor. Now, from here to here, I can replace this resistor as in series. These two resistances are as in series. So their resistance is, so you know, when the resistances are in series, Rs equal to R1 plus R2. We have studied it in the 10th standard itself. So you need not worry about that formula. So here it is 9 plus 3, that is 12 ohm. Now that 12 ohm has to be put instead of this 9 and 3, and it has to be put parallel to the 4 ohm resistor. So here is a 4 ohm resistor. So it is parallel to this 4 ohm resistor, because when you replace it, you have to replace that resistor here, 12 ohm. If you remove this, then 12 and 4 are in parallel. So how do you find out what is the parallel equivalent? So Rp is equal to R1 R2 by R1 plus R2, or 1 by Rp is equal to 1 by R1 plus 1 by R2. So I will apply this directly. Rp is equal to R1 R2. So this is the 4 ohm and this 12 ohm. 4 into 12 divided by 4 plus 12. That makes 48 by 16, it's 3 ohm. So we have replaced 3 resistors now. Finally, we got the equivalent answer as 3 ohm. So 3 and 9 in series, 12 parallel this 4, 3 ohm. That 3 ohm has to be replaced between these 2 points. So when you replace that 3 ohm in parallel to this resistor, which one? The resistor is, it is the 3 ohm is the equivalent of these 2 points. So I can replace that 3 ohm here, 3 ohm. So when I replace that 3 ohm here, what is the equivalent of 6 and 3 parallel? 6 ohm and 3 ohm in parallel. Once again, the equivalent of this is Rp is equal to 6 into 3 divided by 6 plus 3. That is 18 by 9, that is equal to 2 ohm. So finally, the circuit is like this. Of course, I don't replace this final 2 ohm, whatever we have got the answer here, that 2 ohm and this 12 ohm. I don't replace them because I have been asked to find out what is the voltage drop across the resistor R1. So I don't remove R1. So I'll write the equivalent circuit. So I have the circuit like this, 16 volt battery and a 12 ohm resistor here, and the remaining 2 ohm. This is 16 volt, 2 ohm. So I can find out what is the current in the circuit from positive to negative like this. Current in the circuit is given by I is equal to E by R plus R. That implies I is equal to E. E is 16 divided by total external resistance is 12 plus 2 plus internal resistance 2. So that comes to 16 by 16, that is 1 ampere. So once you get it as 1 ampere, what is the current through, voltage across 12 ohm. So voltage across 12 ohm is, you can use V equal to IR. That implies voltage across 12 ohm is I is 1 ampere, or resistance is 12, so it is 12 volt. Simple. So what you have to do is, you have to replace all these resistors, 9 and 3, 12, 12 parallel 4 is the 3, then 3 parallel 6 is again 2. So replace all the resistors one by one, then make the simplest circuit like this, and then find out the answer. Thank you.